Okay. So what have you learned so far? In the first session, we checked what are the properties of Python. Most importantly, we can use ready-made code in Python. I told you, lot of ready-made code is there. So it was just a gentle introduction of Python in our first session. And remember what I am going to teach. My name is Samir. What I am going to teach is efficient use of library and ready-made code. So I will tell you how to copy and paste and how to make your programming faster in Python. But initially we are going to learn core Python. So while we are learning, in first few lectures, then we will not copy or paste anything. We will try to become programmers. Once we become efficient use of statements of Python, we know how to do, and we become confident enough, then we will go for ready-made code. Okay. Then I taught several areas where Python is used. And most importantly, I taught installation, how to install Python. And I hope everybody has installed Python. Remember Python IDLE, IDLE. We installed it. Very simple software. Then I taught what is variable, what are data types. And in the previous class, after learning data types, we learned operators, mathematical operators. Recall, just a second. Recall, we have so many operators, right? And two divisions were there: single divide, double divide, float division, floor division, and then remainder and raised to, that is exponentiation operator. We learned several things about this. Okay, now today's topic, is if statement. We have reached up to a point where we are going to learn a chapter. New chapter is starting now. The name of the chapter is control. You can write down. The name of the chapter is control statements. Control statements. Or many people call this as control structures. Both words are same. We are going to learn three control structures: if else, then for loop, and then while loop. These are the three major control structures in Python. Today we will learn if else. Last time I promised that we will increase the programming exercises because this is a programming class. So we should try to learn as many programs as possible, correct? So today I plan to teach 12 programs. Last time I think we learned 5 programs. So our appetite of learning more and more programming should increase day by day. Okay. So why this chapter is called control statements? What are we controlling? So why are we calling this chapter as control statements? Now just imagine we have written some program in Python. Okay. This is line 1, some statement you imagine, and these are statements we have written in Python. Okay, some program we have written. Just imagine some statement, some statement, some statement, and so on. And you tell me, whenever you run Python program always runs from top to bottom. That is, first statement that you have written will run, then second statement will run, then third statement will run, correct? Sequential execution happens. Now imagine we have a requirement that this line runs, then next line runs, then next line runs, and suddenly when this line runs, control, check the word, control should go back again and run this line again. And then after running this line should run again, then back here, then again this line should run, then control should come down. So these two lines, should repeat. We are supposed to create a loop here. Usually what is the control flow? Check my words. Control flow. Control flow is top to down. But as a programmer, we want to sometimes send the control up again. Repeat. Then again up. Repeat. So are you understanding why this chapter is first of all known as control statements? We will have some statements in Python which will tell the control, don't go down, go up. Correct? So we are controlling the flow of the program. That is why the chapter name is called control statements, right? Okay. Out of that, first control statement is if else. Now, if else is called conditional statement. Conditional statement, or many people call this as decision making. Decision making. I always tell my students that if else is not new to you. Everybody knows about if else. In fact, our life is full of if else, correct or not? If you ask me, describe somebody's life, then there will be a lot of if else. If this would have happened, this would have happened, but it didn't happen. So I went for something else. If else, nothing else. The only thing, what you have to learn with me is grammar, how to write if else. Otherwise, what is the use of if else. We want to make some decisions and so on. Okay, so very quick, huh? This is nothing extraordinary here. Very quick, I will go through if else. Okay, I am very soon coming to chat. Okay, look, we are learning if statement. If is not a function, huh? If is a statement. Okay, it is a conditional statement, as you can see. Okay. Let's see what is the syntax of this. Syntax means grammar, how to write if else. See, after if, you write some condition. Condition is a question which will have answer in true or false. Okay. If condition, note after condition we have colon over there. We have this colon, not semicolon, colon. And then we have written statement 1, some statement you imagine. Statement 2, again some statement. Then we have else, colon again. Then statement 3, statement 4, statement 5. Now, did you observe something in the grammar? These two statements, statement 1 and statement 2 are indented. See, statement 1 and statement 2 are not exactly below this if. Oh, they are indented. It's like we have hit a tab or hit space and taken them inside. But this else, you see, just observe the syntax. This else is outdented again. Outdented. See, it is exactly under if. And then statement 3, 4, 5, are indented. How you read this is like this. If this condition is true, let's say some question we are asking, if it is true, then these two statements will run. Okay, if the condition is true. And these three statements will not run. Which statements which are written in else will not run. Whereas if this condition is false, we are asking some question and it is false, then else will run. And whatever you have indented in the else will run. Super simple. Okay. Now, very quickly, we will turn to an example. Okay. Here we go. Check this. Have a close look at this. And then I will go to Python idle and type it. This is just first example in 12 examples that we are going to learn today. We will increase the number of programs that we learn. Okay. Look at this example. It is very much readable, isn't it? I mean, the only qualification needed to understand this is you should know English, and you know English. Okay. What is that we have written? If, then condition, you see. 4 greater than 3. We are asking, is 4 greater than 3? And this condition, you see, is written in the bracket here. Okay. Bracket. It's written like this. If bracket 4 greater than 3, then colon. But this bracket is optional. This bracket is optional. You can write it like this. If 4 greater than 3. Like this also it is correct. But I have a habit of giving bracket. It increases readability. Fine? Okay. So what have you written? If 4 greater than 3. Tell me, isn't this true? Yes. 4 is greater than 3. Then these two lines will execute, which we have indented. Okay. But else will not run. Okay, let's see. 4 greater than 3 is true. So this line runs. Print A. So A is printed on the screen. Then this line also runs. B is printed on the screen. But else does not run. Take it. Wait a minute. Else does not run means what does not run? Else does not run means whatever we have indented in the else part does not run. So if you are asked, what does not run now? See, in the else, we have written this indented statement. This does not run because condition is true. And after this, control will obviously come to the next line because if else is over, because the condition was true, it printed A, it printed B, else did not run, and next line will run. So D will be printed, then E will be printed. What I mean is that these two lines, are part of our program. They are in our program. Print D, print E are inside our program, but they are not part of if else. Are you understanding? So after the if else executes, that two lines will run, and whatever are the next lines you have written, will run. So how do you read this in general? What is the way out? If you are asked, read this in English. So you will say, if that condition is true, then two lines will run. Print A, print B. If that condition is not true, false, it is false, then else will run, and in the else there is only one line, print C. But print D and print E will run, definitely run after if else. Okay. So now I will type this and show you in Python idle. You would say, what is there in typing? We will type, sir. But let me type at least one code. Later we will see how much code we will waste in typing. Okay. Let's see. I am starting Python idle. It takes time. I don't know why to start Python idle. Okay, it has started. I'll just maximize this window. Where is the cursor? Yeah, I got it. Okay. Now, let's create a new file. Okay, new program. I'll maximize this. What did we write? If 4 greater than 3. Remember, bracket is not necessary. Then you write colon. Okay, and then hit enter. Now you tell me, usually when you hit enter, the cursor should come on the left corner of the screen. Oh, come on, everybody knows this. But now I am hitting enter, watch. After that colon, I am hitting enter. Look, where is the cursor? It is not at the corner of the screen. This is known as indentation. Now, whatever statements we will write here, indented, whatever statements we'll write, are tied with true condition. If the condition is true, then these lines will run. And what did we write? Print quotation A, then print quotation B. Correct. This is it. I want only these two lines to run. As a programmer, I have decided that if the condition is true, I want to print A and B. But now I want to type else. Now else will not be typed here. Else is a word which says that if the condition is false, what is to be done? Else is connected with false condition. Then what you should do is, you should hit backspace key labeled here. Hit that backspace once, come back to the left corner. And now you see you are exactly under that if. Now you type else colon. Okay. Now you tell me what will happen when I hit enter. Colon is there. So when I hit enter, cursor will be indented. You see? Yeah. So now whatever we are writing, is with the false condition. That is else part. So if I print C, C will be printed only if the condition is false. Okay. Now look. I don't want now extra statement in the else. Just a second. I'll come to your questions, but please keep putting your questions. Okay, so now I don't want any statements in the else. I want to come out of else and if else itself. I'm going to say if else, this is you. But now my rest of the program. So I'll hit backspace again. That's it. Now I am out of boundary of else also. Now I will write print B and print E. Now you already know what is the output. How will the Python check this? Is 4 greater than 3? Yes, it is true. Then these two lines will run. It will print A, it will print B. But remember, condition is true. So else will not run. This entire section will not run. But the next line will run. It will print D, it will print E. So the output will be A, B, D, E. Okay. Okay, I'm saving this with some name. I'll give trial.py. I'm saving this file. It already exists. I will overwrite trial.py. Let's run. You see ABDE is the output. Okay, just check. If part got executed because condition was true, else did not run, and those two lines written outside if else got executed, D and E. Okay. Now, suppose I change this condition. I ask, is 3 greater than 4? Like that I am asking. What will happen? 3 greater than 4 is false. So these two lines will not run. Because if statement is false, if condition is false, and if the condition is false, 3 greater than 4 is false, then else will run. And in the else, we have only one line indented. So this C will get printed. A, B won't get printed because this is the line which is running. And after that, obviously, rest of the program will run. So this time, the output will be CDE. Okay, let's try. I'll save this and run it. Yeah, CDE. Okay, that's the way how if else works. And while typing, you have to just take care about this. Now, I will just for fun, I am just typing this again. Huh? Just don't mind. I'm typing this again. Okay. What was our condition? If 4 greater than 3, colon. I said, when you hit at colon, cursor is indented. No, don't play with this unnecessarily. It is helping us. That look, Python is saying now type your statement from here. Don't disturb it. Now imagine I disturb it. I hit backspace. I should not do it, but I hit backspace and I say print A, and print B. Suppose like this. And then else also I am typing here, else at the look, indentation. It is helping us actually that it is saying that you type from here, but I outdent and I say print C. This is wrong. Just check. This is wrong. Python works on the basis of indentation. You have not indented the code. I'll write the next lines also. Print D and print E. I made a mistake. Here was colon character was there. Okay. I'll save this and I'll try to run it. Huh? Oh, look at that error. Look at that. It has given syntax error. I don't know whether this is readable to you, but I'll read it for you. Expected an indented block. Expected a block. Block means several statements or one statement. Single statement is also okay. But block should have been indented after if statement. Are you following? So how do you tell Python that what is related with if? How much to run if the condition is true? You say, look, whatever I have indented, you run if the condition is true. Right? So indentation is must. It is needed. Okay. Now I have disturbed the wrong indentation. How do I do correct? Should I type the whole thing again? No. What you can do is just check. You go to this line. You go to the beginning of this line. This line I have clicked here and press tab. TAB character. Tab. Correct indent now. The next line also, I'll hit a tab. This is correct. Then else, what did we need in else? We said if else executes, print C. And then print D, comma E. This is going to run correctly. It is going to print A, B, D, E. Indentation is needed. Okay. Right. So this is how you type if else. Okay. Let's practice this as much as possible. Huh? All your difficulties will be how to print else statement, sir. How to print? See, it's not about how to print. This print statement will run if the condition is false. Are you understanding? It depends on the condition. Like if I change the condition, if I say, is 3 greater than 4? Then what will happen? Ask yourselves, what will you do? You'll say 3 greater than 4 is false. So you will say, I will run the else portion, and now C will get printed. But these two lines will not run, because these two lines run only if the condition is true. I hope you got this. Now here is example 2. So what is happening here, is that, look, variable A in the memory A is 2, in the memory B is 4, and in the memory C is 8. Then we are asking, if A greater than B, then what Python does is it substitutes the value of A and B. While execution, it knows in the memory A is 2, so it will check, is 2 greater than B? B is 4. No, this is false. 2 greater than 4 is false. So else will run, and else runs means it doesn't mean that entire program after else runs. What runs if else runs is whatever you have indented in the else. So this line, you see, this line is indented. C should become C by 2. Now C is 8. So C will become C by 2 is the statement. This line is running. What it means is C should become equal to C by 2. That means C should become 8 by 2. That means C should become 4.0. 4.0, na? This is floating point division. If it was double slash, then it would have been 4. It is single slash, so it is 4.0. So the output is going to be 4.0. But I'll take your answer. 4 is the correct answer. Now, some guidance on this statement. See this statement, C is equal to C by 2. How you should read this? You should read this line as C takes the value of C by 2, like this. Like this you should read. And whenever this statement, such a statement is there, that something is becoming equal to something, then always solve RHS first. Close the LHS. Don't read LHS. Read the RHS, solve the RHS. So how will you solve RHS? 8 by 2. 8 by 2 is 4.0. Now you say this 4.0 will be stored in C. That means C will no more be 8. In the memory, C will change to 4.0. It is a variable, and variable has changed. C has become 4.0, and then we are printing C. So output will be 4.0. Sir, but why 4.0? We have given int value. Yeah, but a statement division always gives a float answer, and double slash gives integer answer. So what did we write here is A, I think, was 2, B was 4. Look at this, C was 8. And then if we wrote A is greater than B, this was false. But we said if A is greater than B, C should become C into, I think, C into 2. If A is greater than B, then C is C into 2. Then I will hit backspace. I'll type else. C is C by 2. Correct? And then hit backspace and I'll print C. Now, if I save this and run it, you will see the answer is 4.0. Whereas, if this statement was C is equal to C integer division 2. Now, if I run this, the output will be 4. We learned this in operators. Float division and floor division, correct? Now you see, I have given double slash. Then C will not be 4.0. C will be 4. Look at the last answer, 4. It is not 4.0. Here it is now. Now, one thing I want to tell you about if else. See, every if does not have else or need not have else. So we can write if like this, you see. If some condition we are testing, colon, then we have written some line 1. Imagine some statement we have written, line 2, line 3, then line 4, line 5. Look look at the outdented statements, line 6. Have a cool look at this first. What are you saying? If the condition is true, you are telling what is to be done. All this is to be done, should be done, if the condition is true. But what if the condition is false? If the condition is false, what happens? Else runs. If the condition is false, else runs. But we have not written else. In this if, there is no else. Then it means if the condition is false, listen very carefully. If the condition is false, don't run this. Because this will run only if condition is true. If the condition is false, don't run this, but continue with the rest of the program. That means we don't want to take any special action if the condition is false. See, in real life also, many ifs do not have else. Like imagine I say, look at this statement. If it rains today, I will carry umbrella. I repeat my statement. If it rains today, I will carry umbrella. Isn't that enough? Or should I say, if it rains today, I will carry umbrella, else I will not carry umbrella. Or you will say, what, sir? Why you are telling me that? It was clear what you will do if it does not rain. Many times, if may not have else, it depends on our application. Okay? So this is another form of if else. Now you go through that code written on the left. See, A is 2, B is 4, C is 8. If A greater than B, we are saying C should become C into 2. That means C should take value C into 2. You watch, A greater than B means we are asking is 2 greater than 4. This is false. As this is false, this line will not run. Because if is false, then generally what happens? Else runs. But we have not written else. As we have not written else, rest of the program will run. And the rest of the program is print C. And C is still 8. See, there was no change made in C. C did not become C into 2. So 8 will be the output. Correct? And you must have given that answer already, I know. 8, correct. 8 is the output. No else here. Just check this. Slowly and steadily we are learning about how if else works, okay? And trust me, we have got many, very interesting examples. And all examples that I generally take, are engineering based, okay? So let's see example, some more things I would like to tell. There are relational and logical operators. Now this relational operators, this relational operators are also known as comparison operators. Comparison, because they compare values. Like greater than is a relational operator, less than. Okay, greater than or equal to. You write greater than or equal to like this, less than or equal to. Then not equal to is written as exclamation followed by equal to. In Python, exclamation symbol is read as not. Anywhere you see exclamation in Python, you read it as not. Exclamation is not aha. That is in English. Exclamation. Here, exclamation means not. So what have you written? Not equal to. This is not equal to. Then how do you check equal to? Equal to equal to, like this. Double equal to. Not single equal to. Single equal to is used for assigning left hand side to right hand side. Like C should become C into 2, like that. Then you write single equal to. But when you are asking question, then it should be double equal to. Is A equal to B? If you want to check, then you will write like this. If A equal to B, like this, colon. Not single equal to. Okay. Because when you write single equal to, what will it mean? Tell me, what will it mean? Are you asking question? When you write A equal to B, are you asking question? No. You are telling Python that A should become equal to B. You are not asking question. You are making A equal to B. And when you have if statement, you should have a question. So it is double equal to, which helps you to check whether two values are equal. Okay, this is what I have described, on the next page. See these relational operators. These are called relational operators. Double equal to, is equal to, then not equal to, greater than, less than, greater than or equal to, less than or equal. Okay, and I have given some examples. Just check these examples. Suppose x is 10 and y is 20. Two variables. Then if x equal to y will be false, isn't it? Because what we are checking is value of x, which is 10, is it equal to 20? That's false. So this condition will be false. If x not equal to y, yes, that will be true, because 10 not equal to 20 is true. Then is x greater than y? That is false, because 10 greater than 20 is false. And is x less than y? 10 less than 20 is true. So all these are known as comparison operators. Okay. Same page has got repeated by mistake. Then we have got logical operators. I'm coming to chat if you have any questions. Logical operators. Now, luckily, I am talking in the engineering class. These logical operators are based on logic gates. And I'm sure everybody knows AND gate, two input AND gate, one output. Then OR gate, two input OR gate, one output. And you also know NOT gate, inverter. Single input, single output. Correct? What is the rule of AND gate? Output will be 1. When will be the output 1 in AND gate? Only if both the inputs are 1. High. High and high gives always high output. Correct? Both inputs, if 1, only then the output will be 1. Otherwise, output will be 0. So what if you give the inputs as 0, 1 to AND gate? Output is 0. You understand that. You know AND gate, right? And what about OR? When is the output 1? If at least one of the inputs is 1. If both are 1, still the output will be 1. So what if you give 1, 1 here to the OR gate? 1 or 1 is 1. But if you make this as 0, 1 or 0 is also 1. But what if both are 0? 0 or 0 is 0. Both inputs are low. OR gate. Achha, what about NOT gate? If you give 1, output will be 0. If you give 0, output will be 1. Inverter. It is inverter. Okay, even if you don't know this, that doesn't matter. You don't have to be electronics engineer to know AND. I was just giving you a reference. Imagine, I consider somebody may not be knowing logic gates. But everybody knows what is the meaning of English word and English word OR. So what is AND? It is an operator in Python which returns true if both conditions are true. So suppose I write like this: if 4 greater than 3 and 10 greater than 8, colon. Now I am asking that is this true and this true? Listen, if both are true and has been used, if both are true, only then this line will run, which is indented. Otherwise, else will run. Both the conditions should be true. Don't worry, if you are new, you will understand this very well. Huh? And what about OR? OR means, if I say, imagine here, I write OR. I am checking two conditions and I am saying if at least one of this condition is true, then run this line. But if both are false, then run this line, else. And not reverses the result. True becomes false, false becomes true. Okay. We will currently concentrate only on AND and OR. We will not touch NOT at the moment. Excuse me for that. But how many operators we have seen? Relational operators. How many relational operators? 6. 6 relational operators. Greater than, less than, greater than or equal to, less than or equal to, not equal to, and double equal to. These are relational operators. And logical operators, and, or, and not. Not is written like this in C language. But here we write N-O-T, not. And was written in C language as double and, like this. Or was written as double pipe, and not was written as exclamation. But we don't have any such symbols in Python. We use the word and, or, and not. Okay. Let's see some examples of and. Okay. And we will type it also and see. Okay. Just check this. X is 10, Y is 20. Observe. So in the memory, variable X is storing 10, Y is storing 20. We are asking, is X greater than 5? So X is 10, 10 is greater than 5. So the first condition is true. What Python will check is this first condition is true. Then second condition also will be checked. Is Y greater than 15? Y is 20. So 20 is greater than 15. This is also true. So how do you read this? If true and true, both are true. As both conditions are true, total condition will be true. Entire condition is true. When is the entire condition true? If both are true. Okay. Just check this. Next condition. If X is greater than 15, true. Oh, I'm so sorry. X greater than 15 is false. 10 greater than 15 is false. And then or is used. Second condition is checked. Second is Y greater than 15? Yes, 20 is greater than 15. This is true. So false or true it is. False or true. Now at least one condition is true. We have used or. Then the entire condition will be true. This condition is true. So even while speaking, we say, if it is holiday or it is raining, then I will go for picnic. So either of the two conditions have to be true for us going for picnic. Here, one of the conditions is true. So the entire result is true. Okay. I told you we will not see not. At the moment, I am not teaching not. Okay. How do you read this next condition? Is X exactly equal to 10? Double equal to? Yes, it is. X is 10. This is true. Is Y less than 10? Y is 20. 20 less than 10. 20 less than 10 is false. And we have used and. Now, true and false is false. Both should be true. Only then and will return true answer. Okay. Why do you need this? Why do you need and or? Because several times we want to check multiple conditions. Multiple conditions in if. In if. Single condition is not enough. Many times we want to know, is this condition true? Then we have got one more condition. Then we have got one more condition. And then we have to build a logic. Logic is, if all of them are true, only then run this line. All of them means we'll use and. And many times we say, if at least one of them is true, then we will use or. So and or are used whenever we have multiple conditions to check. Okay. So let's see some more examples. By the way, here I have given truth table of logical operators. I'm going to share these notes with you. After the class, I will just share the PDF. This is a PDF. I'll share these so that you also have a track of what was learned in the earlier class. Explain with three conditions. We have that. Immediately we have. Okay. So and operator, you see true and true is true. True and false is false. Correct? False and true is false, and false and false is false. So when is and true? Only when both are true. True and true, only then you will get true. What about or? If at least one of them is true. Both are true, result is true. One of them is true. You say true or false? True. False or true? True. But false or false is false. Okay, let's see this. Example 4. Now here, the solution is not given. We have to think of solution. Read the program very carefully. Read the question, write a program to check whether a person is eligible for blood donation or not. A person is eligible only if age is between 18 and 60 and weight is at least 50. So a person going for blood donation and age is, let us say, 15, then person is not eligible because age should be between 18 and 60 and both inclusive. Exactly 18 it can be or exactly 60 it can be. What if a person has age 40, 40? Is that person eligible? Yes, because age is between 18 and 60. Age is 40, but weight of that person is 35. Then that person is not eligible. That person is underweight. So many conditions should be true so that person is eligible, we can check. Now, first question is to write this program, what are the inputs? What are inputs? First question. Do you understand? We should ask age and we should ask weight. Let's take variable age and W. Or you can take A and W. A for age, W for weight. Two inputs will be there. Correct? And let us take both as integers. We can take weight as float also, but let's take both as integers. Correct? Then what should be the output? What is the output? Output should be like, congratulations, you are eligible. Some message like that. So it should be eligible or not eligible. One of this. One of this will be the output. But how is this output going to be decided? By using if else. Because once we enter age and weight, we will then check is age between 18 and 60 and is weight at least 50. So first lesson, I will give you how to check whether age is between 18 and 60. Okay. You might have number of things which are valid in your mind, that you may be already knowing how to write this condition, but I'll tell you a neater way and you follow that way always. If you want to check is age between 18 and 60, then I'm just erasing this. Then how you should write? Age is between 18 and 60. You should write if, let's say A is the variable for age. If A is greater than or equal to 18 and A is less than or equal to 60. Like this you should write. I'm not saying whatever your method might be, you type it, you see it works. Okay, I'm coming to what you are thinking. But this is a legible and neater way of writing. What are you asking Python? That check whether age is, look at the number line. This is the number line. This is 0. Somewhere here 18 is there. And somewhere here 60 is there. And somewhere here 100 is there. Number line, you imagine. And you are asking, is the value of A exactly, you understand, greater than or equal to means exactly equal or greater. Greater than or equal to. Greater than or equal to means it can be exactly 18 or above 18. And check this word and. Is the age exactly 60 or less than or equal to 60? You are checking this range, greater than or equal to, less than or equal to. And this condition will be true only if age is really between 18 and 60. Okay. Then one more condition we need, and weight, let's say W is the weight, is at least 50. At least 50 means 50 or above. It can be exactly 50 also. So how will you write that? Greater than or equal to 50. So if weight is exactly 50, equal to 50, even then it works. And if it is greater than 50, even then it works. This is how you should write the condition. Now, some students might think that even this is correct if 18, look at this condition. You are saying is A greater than or equal to, look, greater than part is towards A, 18. And is A less than or equal to 60? Very correct. In Python, it works. If you write condition like this, trust me, it works. But my appeal to all of you is don't write conditions like this. Why, sir? Just like that. It is more readable. That's why I'm saying. See, this is not readable. Although you might be eventually habituated to theta between 0 and 90. So many times we write this. Huh? But let me tell you, when we have advanced conditions, then you have to develop the skill of writing and not going to that arithmetical way of writing that you see in the geometric books of geometry. We need to write it in programming style properly. But I leave it to you. See, if you are comfortable with this, you can. But we are going to follow this style, okay? Anyway, somebody was asking, sir, write if with three conditions. So this is example with three conditions. Okay. Now here is my question. Suppose you want to check, is salary between 10,000 and 50,000. Now, whenever it is 15, whenever it is between, it is both inclusive. It can be exactly 10,000 or above, or it can be exactly 50,000 or below. It should be between these two. Then how will you write this? If S, let's say S is the salary, is S greater than or equal to 10,000, like this, and is S less than or equal to 50,000. Good. I think I am not getting disconnected. Okay. This is the way how I will check it. Okay. See, is S between 10,000 and 50,000 using AND. Remember from now onwards, whenever you want to do range check, do it like this. You will be most comfortable. So are we ready for the program? This is example 4. But this is the way how every programmer writes, believe me. In any textbook also you will see this, because this is more easier to read. Greater than or equal to 10,000, less than or equal to 50,000. So legible. That's why we write this, okay? And C, Java, and C++ programmers follow this rule. In C language, if you try to write this condition, it will not work. If 10,000 this way, if you write in C language, it will not work. In C language, it strictly says write a different condition, then different condition, and then you add. We follow that. Okay. So going to Python idle, what was our question? Input age and weight. So first we'll take A is equal to int input, enter age. Okay. And then weight is equal to int. You can take float, weight as float, input, enter weight. Then if we want to check is age between 18 and 60, both inclusive, both inclusive. So A greater than or equal to 18. It can be 18 or above, and at the same time, age should be less than or equal to 60, and weight should be at least 50. That means weight should be greater than or equal to 50. Colon, don't miss colon grammar. Then inside this if, we will give print eligible like this. Then we will hit backspace. Else, what are we saying? That means if person doesn't fit in these rules, then else look at the indentation again. Print not eligible. And after that, what will you do? Nothing. That's it. You don't even have to hit backspace. If you hit backspace, it's okay. But your program is over. You wanted to only check whether eligible or not eligible. After that, you don't have any statements. So after this if else, your program is done. Okay. Now, Before you run the program, just think of this. Suppose you enter the value of A. Imagine A entered by you is 40, and weight entered is 65. So what is A? 40. Now, how will Python check this? Is 40, because A is 40, is it greater than or equal to 18? Yes, 40 is greater than 18. So the first condition is true. Then it will check, is 40 less than or equal to 60? Yes, 40 is less than 60. Second condition is true. So you see, and both conditions are true, correct? But one more and is there. Weight, what was weight? 65. Is 65 greater than or equal to 50? That is also true. Then all the conditions are true that we have written using and. So eligible will be printed and else will not run. So if I save this and run this, it is asking me age. I will enter age as 40 and weight as 65. See, it is saying eligible, right? So this is the way how we have written this code. Yeah, eligible, correct. So those who are still wondering why that condition should not be written, okay, let's try that kind of condition. Okay, we were saying 18 less than or equal to A less than or equal to 60, like this. And then I have written and W greater than or equal to 50. I was saying that if you write such a condition, let's give the same input. 40 is the age and I think 65 is the weight. See, eligible, still it works. Such a condition very well works in Python. But my appeal to all of you is you write proper, different conditions you write and tie them using and. Okay. So our condition was A should be above 18 or even equal to 18 and A should be below 60 or above even equal to 60. About this, I hope you understood the code and I hope you understood ANDing. I'm changing the page. I hope you have written this or you have taken screenshot of this because this program is not given in the notes. I think only question, or let me check the next page. Maybe the program is given. Oh yes, the program is given. Fine. This is exactly the program we wrote. Just imagine that age entered by someone is 8 years. Age is 8. And so age is the variable I have taken. And weight entered, let's say, is 15. Okay. Now, clearly this person is not eligible. Now, see how the if works. What is age? 8. We are asking, is 8 greater than or equal to 18? Now, this is false. And what is written after this condition you watch? And is written. And. Now, you only tell me if the first condition itself is false, and after that and is written, then Python will not bother checking the next condition. It will directly jump to else. And it is meaningful, isn't it? Because what is the rule of and? And means both should be true. Only then it will go further. Now, first condition itself is false. 8 greater than or equal to 18 is false. Then it will not even care. Python will not even care to read the next condition. Because it doesn't make any difference whether next condition, if next condition is even true, but ANDing is done with false. So the result is going to be false. So it will jump to else. That if the first condition is false, then does Python check the second condition if ANDing is done? Answer is no. If the first condition is false, Python won't bother. It will directly jump to else. Okay. So this was example 4. Okay, fine. Now, I have given one more solution here. One more solution just for fun. I am not discussing this. Same example 4, I have solved. But this is another way of checking whether age is between 18 and 60. Between 18 and 60. I am not discussing it. I have just given it here. For those who can find out can find out. Otherwise, this word range, range, I will discuss it when I discuss for loop. Then I will revisit this page. Trust me. Huh? But same problem I have solved again using range. If age in range 18 comma 61, 18 comma 61 means 18 comma 60. Let's not go into that details at the moment. Okay. So example 4 is solved. Now I will come to more advanced or more complex type of if else. Sorry, I take back my words. It's not complex. It is also part of our life. Okay, check this. This is known as ladder if. It's known as ladder if. It looks like a ladder. It's a ladder if. Okay. Now you read this. I have written some condition. I have named it as condition 1. Some condition you think. Colon. What I am saying is, if this condition is true, then statement 1 should run. Because come on, if the condition is true, then indented code runs. And what we have indented inside this if? Statement 1. So if the condition is true, I am saying, if this condition 1 is true, then run this statement. This statement runs. And after running statement 1, directly come out of remaining if else and keep running the remaining line, statement 5, statement 6, statement 7. That means if this condition is true, then this line will run and this elif won't run. Now this elif is actually else if. Else if. But there is nothing called else if. Else if was there in C, C++, Java. In Python, we write this as elif. Okay. Now how do you read this? Suppose this condition is true. Then statement 1 will run and rest of the part will be simply dropped, and the statement 5 will run, 6 will run, and rest of the program will run. Okay. But what if condition 1 is false? This is false. Tell me what happens if the condition is false. I repeat, what happens if the condition is false? Else runs. I repeat, if the condition is false, then else runs. And for this if statement, this is the else. This is actually else if. So as this condition is false, now the control will come to else if, and another condition is checked, condition 2. In short, second question is asked only if first question is false. First question was false, condition 1 was false. Then we say, oh, condition 1 is false, so let me check another condition. Are you true? Suppose you are true. Condition 2 is true. Then this line will run, statement 2. And rest of this will be dropped. It will not run. And directly we will come to statement 5, statement 6. I hope you are understanding. Okay. Okay. Just imagine condition 1 is false. So where does the control go? Else if. Condition 2 is also false. Then what will happen? What happens if the condition is false? Else runs. So we have else here. If this condition is false, elif runs. That means else if. That means condition 3 will be checked only if first two conditions are false. So this condition, suppose it is true, then statement 3 will run and else will be dropped. Else will not run because condition was true. And after statement 3, 5, 6, 7, rest of the program will run. I hope you understood ladder if. Tell me then, what will happen if first condition is false, second condition is checked. That's also false, third condition is checked. That's also false, then this else runs and statement 4 runs. Have you noted that in the last else, last else, there is no if. It's like enough is enough. I hope you have heard about this phrase, enough is enough. In our life also, we check something. Can I do this? Oh, I can't do this. Then elif. Let me try this. Is it possible? No. Oh, okay. Elif. Let me try something else. Oh, that's also not possible. Then else. I will settle for something, they say. The last else does not have, it's optionless. I mean, we are running out of options and we execute some default statement then. Okay, let's do this. That is ladder if. Okay, you will understand more about ladder if. Then I will come to your questions. Look at this. Have a cool look at this. Take your own time. I have given you a program. A is 10, B is 2, C is 8. And then look, we are asking a question. We are asking a question. Is A less than B? If it is true, this will run. But if this is false, then elif, this question will be checked. If this is true, then this line will run. But this is also false, then only this else will run. So my question is, what is the total output, overall output of this program? Have a cool look. See, first condition is checked. Is A greater than B? Substitute the values. 10, sorry, less than, I'm so sorry. Is 10 less than 2? False. This is false. So therefore we go to elif and check the second condition. Is B less than C? Substitute the values. 2 less than 8. Yeah, this is true. As this is true, this indented statement will run. So the first output will be Q, then else will not run. Because if it's true, you see, if this condition is true, so its else will not run, and S and T will anyway run because they are written outside if else. So ST. So QST is that. Absolutely right. Both are actually same. Question is, what is the difference between ladder if and nested if? Actually, both are same, but special word is given to that elif. Elif, it looks like ladder. That's why. Even this is nested if. Okay. But see, pure nested if you think of, it will be like this. If some condition, then inside that directly if some condition. This is nested if. Okay. Then we may have else portion. In the else we have if, like this. This is nested if. We don't have elif. We have else if, like that. Correct? This you can say, yes, if is nested inside another if. That's why. Nested if. Okay. Just check. Write a program to input any three integers, A, B, C. Print the largest among the three integers is the question. So what should happen is when the program starts, it should ask us enter first integer. We will, as a user, we will enter 8 maybe. Then it should ask enter second integer. We may enter 2. Enter third integer. Some integer we have to enter, and we might enter 7. Then the output should be 8. The largest between these three should be printed. And we don't know what will be the first, second, third value. Maybe operator enters first value as 2, second value as, let's say, 8, and third value as 17 maybe. Then 17 should be the output because third value is largest. We really don't know who is the largest. That is to be checked. Okay, we will solve this using nested if and using AND operator. Okay, before that, very general. If you have three numbers A, B, C, you want to know who is the largest. Then won't you ask this is if A is greater than both B and C. In English, you will check like this, na? If A is greater than both B and C, then A is largest. But what if A is not greater than B and C? Then you write LF. Are you following? LF. That means if A is not greater, only then check. Is B, LF, B is greater than both A and C. Both A and C. If it is true, then B is largest. But what if this is also false? B is also not largest. Then in the else, you will say C is largest. Oh, come on. No need of asking is C largest because A is not largest, B is not largest, then C is largest. Why will you waste time in asking is C greater than B and A? Yes. This is general way in which you will check who is largest between three numbers. Okay. So this is what we have to do, and I have got the solution. I have printed the solution. Huh? Just check this. Observe this program. Read it carefully. Are you understanding the program? First three inputs we have done. Then we have asked, is A greater than B and A greater than C? Like that. Now the same thing, could have been written like this. If A greater than B greater than C. Like this also you can say. We are asking, is A greater than B and C both? But this is not readable. Trust me. This is much readable. You are asking, is A greater than B and A greater than C? Is it greater than both B and C? If it is true, then print A. Value of A should be printed. But what if this is false? A is not greater, then we will have else if B greater than A and B greater than C. If B is greater than both A and C, then print B. But what if this is also false? Then else print C. Got it, everyone? I hope so. This is the program, right? Okay. This was, I think, example 5. Inputs are same. Good question. Huh? I'm not able to pronounce your name, but it begins with X. Okay. Xiaomi something. But what if two values are equal? Okay. I'll come to your question. So basically, let's test this question, this program. Test the program on paper. Huh? Don't go to Python idle. Test it on paper. Imagine A entered by the user is 8, B entered is 18, and C entered is 3. Then output should be 18. Let's see. Is A greater than B? Is 8 greater than 18? False. 8 greater than 18 is false. Forget it. Don't waste your time in reading and. Don't even read it. First condition is false. So you go to else if. Is B greater than A? Is 18 greater than 8? Yes. This is true. And is B greater than C? Is 18 greater than 3? Yes, this is also true. True and true is true. So this line will run, print B. So 18 will be printed and else won't run. And program will stop. Like that, you can check putting any values of A, B, C, program will run. It will print the largest. Correct? But this program is wrong. Just check. This question was asked, or rather, the student cited this problem very early. Okay. Just imagine A entered by the user is 8, B entered is 8, and C entered is 2. That is, values are repeated. 8, 8, 2. Now output should be 8. Oh, come on. Largest is 8. We want to print largest among the 3. And largest is 8. What if there is a tie? 8, 8, 2. Still the output should be 8. Correct? Output won't be 8. Let's see. These are the values. First if. Is 8 greater than 8? Carefully observe. Carefully. A is 8, B is 8. Is 8 greater than 8? False. Oh, even in Africa it is false. Come on. 8 greater than 8 is false, na? Then forget it. This if is false. And has been used. First condition itself is false. So where do you land? Else. Control comes to else if. Then this condition is B greater than 8? B is 8. A is also 8. We are asking, is 8 greater than 8? That is also false. And has been used. So forget it. This is condition is also false. Then finally the control comes to else. And when the control comes to else, then nothing is checked. And it says execute else. Because everything is false. So execute else. Then it will print C and output. Output of the program will be 2, which is wrong. Output should have been 8. What it means is this program runs properly if the values are different. But this program does not run properly if two values are equal and they are largest. If 882 is the input, 2 will be the output. Okay, let's go to Python idle and spend some time with this. The problem says that input 3 integers. So A is the first integer. I'll put enter first integer. Then I'll just copy paste this. So B is the second integer, C is the third integer. Third, and this is second integer. And now we have checked if A is greater than B and A is greater than C. If A is greater than both, colon means indentation, then we will print the value of A, print A. You could have done this as follows also. A is largest. Like that. Instead, we are just printing the value of A. That's enough, isn't it? Then we want elif. Elif should be written with backspace. Under that if. Elif. Like this. Then what is the second condition? We are saying, okay, A is not largest. Then check, is B largest? B will be largest if B is greater than A and B is greater than C, both. If this is true, then print B. But if this is also false, then backspace. Backspace you push. Else colon, you are saying don't check anything now. Declare C is largest. And after that, we don't have anything to do. We will end the program. Now, my point here is that when we run this and we enter something like 8, 17, 2, then 17 will be the output. If all values are different, output is correct. But if I run this with the inputs 8, 8, 2, then the output is 2, which is wrong. Check, output is 2. What is the mistake we did, The mistake we did is, we did not anticipate that the values might be equal. And luckily, we have an operator greater than or equal to. Instead of simply greater than, we could have checked greater than or equal to everywhere. And this solves the problem. Greater than or equal to. Now you check. With 8, 8, 2, you check. Orally, you check. 8, 8, 2. A is 8. B is 8. C is 2. We are asking, is 8 greater than or equal to 8? A and B both are 8. And 8 greater than or equal to. Or equal to 8 is true. Both are equal at least. 8 greater than or equal to 8 is true. And 8 greater than or equal to 2 is also true. Then it will print A, that is 8, and rest of the else if will be dropped. What did I say? I will go back to the board. Wait. So I got the correct version. So this is wrong. This is wrong. Will not work. Will not work if values, two values are repeated. Okay. So on the next page, I got the correct version. Okay, I'll just go. See this. This will work. Just check. If A entered is 8, B entered is 8, and C entered is 2, then we will be checking is 8 greater than or equal to 8, which is true, and is 8 greater than or equal to 2, which is also true. So now A will be printed, that is output will be 8, and rest of the else if will be dropped. Correct? And what if we give different values? Even then it will work. Anyway, previously it was working. Like if this was 18, 8, 18, 2, still it will work. How exactly? Tell me. How will this run? Is 8 greater than or equal to 18? This is false. A greater than or equal to B is false. And has been used. So forget it. Go to else. This if is false. Is B greater than or equal to A? Is 18 greater than or equal to 8? Yes, true. And is B 18 greater than or equal to C? 2. This is also true. So it will print B. 18 is printed. And then else will be dropped. So for equal or unequal values, it will work. Right? So this is the way how we have checked largest between three numbers. Okay. Now, how will you check largest between four numbers? Oh, good Lord. See, it won't be a good experience. You will say A is equal to input, B is equal to input, C is equal to input, D is equal to input. You'll have four inputs. Then how do you check is A largest? You will say if A is greater than or equal to B and A is greater than or equal to C and A is greater than or equal to D colon, then print A. A is largest. If A is greater than or equal to all, then A is largest. Then you will write LF. B is greater than or equal to A and B is greater than or equal to C and B is greater than or equal to D. Then print B. B is largest. Oh my God, this is going to be a big if else, isn't it? And look at the length of each condition also. You have so many ands, right? And what if there were 5 values and you wanted to know who is the largest? Very difficult then. Difficult means difficult to write because the conditions becomes very big. Correct? Then whenever you have many values, then you use list, tuple, set, dictionary, higher data types you use. Whenever you have multiple values to work. Okay? So that's why we are restricting ourselves only with 3 values. What I was saying, if I have 4 values, then I will have to add one more input. Correct? I will have to put D is equal to input. Just give me some time. Wait. D and we'll say enter 4th integer. But then we will have to now check. First condition is if A is greater than all. So I'll have and A is greater than or equal to D. Then print A. L if B is greater than A, B and C. B is greater than A, C and D. So B should be greater than or equal to D also. Then we will have L if here again. L if C is greater than or equal to A and C is greater than or equal to B and C is greater than or equal to D. Then print C. And finally, finally we will write else, print D. Now D has to be largest. Come on, nobody is largest. Then D has to be largest. So if I run this, I will be asked 4 numbers. Suppose I enter 18, 2. Let's go for tie again. 18, 8. 18 should be the output. Yeah, 18 is the output. 18 is the largest. Okay. So we have already come to 8:30 time. I mean, my plan, I'll just show what was my plan. We can write A greater than B, C, D is the question. Just a minute. The question asked here is, can we write the condition like this? You watch. I'll go to the program. I want to know, is A greater than B, C, D, correct? Then why to write so many times A greater than or equal to B, then greater than or equal to C? A suggestion has come that we can write like this: A greater than or equal to, in the bracket, B comma C comma D. So indirectly, it seems that we are asking, is A greater than or equal to all B, C, D, like this. Similarly, the question asked is, why to check so much? We could have checked in the bracket A comma C comma D, bracket close, like this. And here A C D, A B D, I'm sorry, A comma B comma D, like this. Okay, let's try running this and see what happens. It is asking me 4 numbers, 18, 2, 3, 18. What it is saying is such a format is not supported. You can't write like this. Simple. What it says, this greater than or equal to is not supported with tuple. That means, in short, at the moment, I can tell that you can't write like this. So you will have to write, if A is greater than or equal to B and A is greater than or equal to C and A is greater than or equal to D, like that you will have to write repeatedly. My appeal to all, good thinking on your part. Whatever you have in your mind, you can just put. Okay. What is the use of B greater than or equal to A in second condition? That is L if 1 before if. Yeah, I got your question. If the first if is false, we know A is not largest. Then why to check is B greater than or equal to A? Correct. You can skip that condition. Absolutely. I mean, we can think of reducing by reducing some questions, but ideally, we have asked all the questions in each if. Okay.